Hi, and welcome to the lesson where we will be reviewing polygons and quadrilaterals. Essential question: how can we recall what we know to prepare for an upcoming test on the unit we just covered? So we're going to review the concepts for polygons and quadrilaterals and prepare for the test. Everything in this review was taught in a previous lesson. So I'm taking everything we've learned since we started talking about, since we left triangles and we started talking about quadrilaterals and other polygons. So if you haven't, so this will be a brief overview and a brief review, hopefully refreshing your memory and allowing you to kind of dust the cobwebs off of something that you might have forgot from a previous pod, because I know it's been a long chapter and spring break and everything. So let's just think about the certain concepts, and if you have trouble or you need specific help on a certain content, make sure you go back to that specific lesson video on the course page. Watch that specific lesson or class recordings, and if you still need some help refreshing, you can definitely do the review and come to Math Cafe or set up a time with me and we can go over individually or in live class some areas where you may be stuck reviewing. So first we started talking about parallelograms. What are the properties of parallelograms? If a quadrilateral is a parallelogram, then its opposite sides are congruent. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. If a quadrilateral is a parallelogram, then its opposite angles are congruent. And if a quadrilateral is a paragram, then the diagonals bisect each other. So if you don't have that somewhere in your notes, pause the video real quick and copy that down. The sum of the measures of the interior angles, this is the polygon interior angles sum theorem. So the measures of the interior angles of a convex, remember convex means that all the points lay outside on the exterior of the shape. So there's no points that go in, so there's no like cave-like parts of the polygon. So the sum of the measures of the interior angles of a convex polygon with n sides is n minus 2 times 180. And if we want to find out a specific angle measurement for that, for a regular polygon, meaning all the angles are congruent, this only works if it is a regular polygon because all the angles have to be congruent, and we want a specific angle, we do n minus 2 times 180 divided by the number of sides, because the number of sides is congruent to the number of angles. If a polygon is convex, then the sum of the measures of the exterior angles, one at each point, is 360 degrees. So 360 degrees is the sum of the exterior angles for any polygon. If you want to know specifically of a regular polygon, again, regular polygons, all the angles are congruent. So if I want to know a specific exterior angle, so one exterior angle, I do 360 divided by the number of angles or sides, because they are equivalent. And here's an example just showing that to you, that all the exterior angles are congruent and they add up to 360 degrees. Just a review of a diagonal is a segment with endpoints at two non-adjacent, means they're not next to each other, vertices of a polygon. First theorem when we started talking about rhombuses. Rhombuses are a special type of parallelogram. If the diagonals of a parallelogram are perpendicular, meaning second, that these two diagonals, all parallelograms, all quadrilaterals really, have two diagonals, two possible diagonals. If those two diagonals are perpendicular, then the parallelogram is a rhombus. If one of the diagonals of a parallelogram bisect a pair of opposite angles, then the parallelogram is a rhombus. For example, parallelograms, opposite angles are congruent already, but if the diagonals bisect those angles into two smaller congruent angles, then the parallelogram is a rhombus. If the diagonals of a parallelogram are congruent, therefore all four bisected parts are congruent, then the parallelogram is a rectangle. So a rhombus has four congruent sides. A rectangle has four congruent right angles. Interior angles of a quadrilateral add up to 360 degrees, therefore all four angles would be right. They would be 90 degrees. And then a square has both congruent sides and congruent angles. So all right angles and all sides are congruent. So a square is both a rhombus and a rectangle. Then we kind of talked about the converse of each parallelogram. If a parallelogram is a rhombus, then the diagonals are perpendicular. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. If a parallelogram is a rectangle, then its diagonals are congruent. And just for vocabulary, a parallelogram is a quadrilateral with two pairs of opposite sides parallel. Opposite sides may include arrows to show the sides are parallel. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if DC is congruent to AB and AD is congruent to BC, then the quadrilateral is a parallelogram. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So for example, if A plus angle D equals 180 and A plus angle B equals 180, then in fact that would mean that angle D and angle B are congruent, and therefore opposite angles are congruent, and therefore the only other possible measure for angle C would have to be the equivalent measure for angle A, and therefore you would have a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Like we just said, if angle D is congruent to angle B, angle A is congruent to angle C, then the quadrilateral is a parallelogram. If the diagonals of a quadrilateral bisect each other, therefore split each other into two equal parts, so this segment congruent to this segment and this segment congruent to this segment, then the quadrilateral is a parallelogram. If one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So if AD is congruent to BC and happens to be parallel, AD and BC, then we have a parallel. Another vocabulary word, trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Parallel sides of a trapezoid are called bases. The non-parallel sides are called legs. The two angles that share a base of a trapezoid are called base angles. If a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So just like with triangles, the opposite angles are congruent as well. Opposite this side opposite this side, those two angles are congruent. And now that we have two angles up here, these two angles are congruent as well. If a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So if these two are equal, then you can say that these diagonals are congruent. If a quadrilateral is a trapezoid, then one, the mid-segment is parallel to the bases. So we have the mid-segment MN, which is the segment connecting the midpoint of RT, which is M, and the midpoint of AP, which is N. So MN is the mid-segment connecting the two midpoints. It is parallel to both of the bases, RA and TP. And it is also equal to, MN is equal to 1/2 RA plus TP. A kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. So, like a rhombus, the consecutive sides are congruent. However, the opposite sides are not congruent, and therefore we have two pairs of congruent sides. However, they are consecutive instead of opposite. Kind of looks like a kite you would fly. And special property for them is that the diagonals are perpendicular. This is just a little review reminder of what the coordinate plane is. You have your x-axis, your y-axis, and you have your grid system and your coordinates. 1, 2, 3 in the positive x direction, 1, 2, 3 in the negative x direction, 1, 2, 3 in the positive y direction, and 1, 2, 3 in the negative y direction. Another vocabulary word, classify. To classify is to organize by category or type. You can classify figures by their properties. Example, rectangles, squares, and rhombuses are classified as parallelograms. Key formulas that help us in coordinate geometry to classify are the distance formula, the midpoint formula, and the slope formula. We can use the distance formula to determine whether sides are congruent or diagonals are congruent. So whether two parts of a figure are the same length or not. That's when we can use, that's why we would use the distance formula. The midpoint formula we can use to find the coordinates of the midpoints of a side and to see whether or not diagonals actually bisect each other, which are some properties of certain parallelograms and quadrilaterals. And last but not least, the slope formula, use it to see if opposite sides are parallel, to see if diagonals are perpendicular, and to see if sides are perpendicular. Because if sides are perpendicular, that means the angle they form is 90 degrees, or a right angle. If you haven't already done so, make sure you copy this chart. Make sure you look at it closely. It really lays out all the types of quadrilaterals that we've talked about and how they relate to other types of quadrilaterals. Also, under each specific type of quadrilateral, there are subcategories, and there are also the properties associated with them. So you see here that we have, for example, a parallelogram. Well, all these properties also pertain to both rectangles and rhombuses because they are both parallelograms. And therefore also squares have those properties too, because a square is both a rectangle and a rhombus. A square has all of these properties and all of these properties. And so this is just a nice organizational flow chart with all the information all in one place where you can quickly reference it. So thanks for watching. It wasn't a comprehensive review, but I hope it helped you to think about some things that maybe you forgot. And if you did forget about them, now's a good opportunity to go back to those previous lessons and to your notes and previous recorded live classes and brush up on what you may have forgot. So I hope you're ready for the test. Go ahead, try your review assignment, and let me know if I can help you prepare any more if you have specific questions about specific stuff from the previous chapter. And one more thing, please don't just take the test. Make sure you study. Make sure you really try to refresh, and just make sure you go over everything that you've learned so you can do well.